I want to thank you all for coming, of course, and say that we're going to be doing this. I haven't done a full day thing like this, so hopefully it will all work out and you'll be sufficiently captivated by everything that happens. I set up 3 specific modules. The first one is just a general, is what I called in just a real introduction to Python. My approach is perhaps a little bit idiosyncratic, and you'll see why and how that is the case in a few minutes. The second module will be building on what we learned in the first module, and what we will be doing concretely is we will be building a data set out of articles for the Journal of Political Economy. So you will be able to build this data set on your own, and you'll see what it's like. And you'll see what it's like to sort of start thinking about whatever kind of work you want to do in a kind of data environment. And then the third part of the third module is we're going to ask I was about to say a concrete question, but it isn't a concrete question, because what we're going to do is we're going to look at the JPE's relationship to publishing female authors. And we're going to see what we can, if we can figure anything out about that. So that's how we start, and hopefully the modules will end along with the time that we have set up for things to end. I think I put in a lot of space for confusion and questions, etc. Speaking of questions, so Dan and Madiha introduced themselves. If you have any questions, there's also room, if you aren't up against a table, there's room up here. It's a bit of a tight squeeze. I guessed the capacity of this room, and I think I over-guessed it a little bit. So please, everybody should be able to be up against a table for your laptop. Also, there's a cardboard box in the middle of the room that is full of surge protectors. So when you will need to charge your laptop, you can grab one of the surge protectors, and there's outlets all along the wall, so you can just figure that part out. Okay, so one more time, this URL here, I am going to take it down in a little bit. So for those of you who just showed up, take a picture of it or something, because it's going to disappear in a second. But this URL is where we will be doing all of the stuff that we will be doing. And now with that, I'm going to switch over here, and you're going to see OBS for the last time, because now everything is going to happen in the browser from now on. So this URL takes you to this page. And this is a website called GitHub. I'm not going to explain what it does or anything like that. What you need to know for today is that it is where that URL will always point to here. And this is a project called the Columbia Data Club Meetings. And in the meetings, there's a folder called WIS. That's you all. And inside that folder, there's a folder called 2023, which is today's workshop. There's only one workshop for you all in all of 2023. And here are the 3 modules. So if you click on one of these modules, on the first one, please only click on the first one. You see it'll take a second to load. And you see there's this button here, Open in Colab. I suspect it won't open in a new link, but if you click on it, it will open up and take you to something that looks like this. And I'll zoom in. This is what we're going to be working with. So you can see that the first section here is a little bit about Python resources, and then I'll explain what this website is in a second after that. So first I want to start with talking to you about Python resources at Columbia so you can get a sense of what kinds of things are available. Research data services, I mentioned earlier, that's my colleagues and I who work with research data services. Here, this leads to our website. Here's our email. Sort of one way of thinking about when to contact us is the second you are creating a spreadsheet for your like capstone project or something, the second you realize you're using a spreadsheet, you should consider calling us or emailing us, because we may be able to help you figure out the best way to handle that spreadsheet. Data Club, I mentioned, this is sort of a hors-série version of Data Club, like it's out of the regular series of things because it's to a special audience, you all. But here is the link to join the email list. And then Foundations for Research Computing, we actually do provide, the libraries with partners, with campus partners, do already provide day-long Python workshops. It's actually 2-day-long workshops that have a Python component and a component on using Git, which is a piece of software, and on using the command line. And they also offer those workshops in R, so Python or R. And this is why I said I would be mentioning Dan again in a few minutes, because Dan is in charge of the Foundations for Research Computing workshops. So if you click through here, you will be able to see how to sign up for that sort of stuff, to sign up for the workshops, etc. The workshops are, like I said, 2 days long, and they tend to be, there's typically one in January and one in August, I want to say. The materials used in those workshops come from a group called the Software Carpentry. So even if you can't come to those, go to those workshops, you can click through to the Software Carpentry website and see plenty of tutorials for working with Python or any number of things. Finally, this is especially important to you, or sorry, relevant to you as SIPA students, is that a couple years ago, like about 10 years ago, Columbia put together this course called Computing in Context for undergrads. And the point of the course was to sort of have a Python 101 course for English majors, and then a slightly different Python 101 course for econ majors. And then they also made one for SIPA students. So you all are unique, I think, among Columbia graduate students in that you have a specific Computing in Context section for yourselves. I think this is usually only offered in the fall, so it's probably too late to take it this year, but next year perhaps, or so on and so on. So those are the Columbia resources. There are some other resources here that I put together about different groups online and different, like a book, Think Python 2E, and these are things that you can always look at later. So I think, no, I don't really, okay, so before I talk about this website, I'll talk a little bit about what's particularly idiosyncratic about this workshop. Is I personally don't really think that it makes sense to learn Python, because I don't think that that makes sense as a goal. A computer language is not like a human language where you have to learn English so that you can do stuff in America. With a computer language, you can learn only what you need to learn. And with a computer language, with a programming language, it's often predictable what you need to learn. So I get frustrated when people come to me and say, I want to learn Python, because that in and of itself is, I mean, that's like, I want to learn English. Okay, well, why do you want to learn English? Because I want to move to America. Okay, so you need to learn how to interact with the government. You have to learn how to talk to the border guard. You have to learn how to talk to administrators at Columbia. You have to learn how to talk to landlords, how to eat, like it's all these different kinds of things. So learning Python is the same thing. Like, I want to learn Python means that you hypothetically have a foundation to do climate science, to build web pages, to do genealogy, to do music. any number of things you could conceivably do with Python. So for me, or any programming language, but particularly for today, for Python. So for me, it's always a little bit peculiar to say like, well, sure, we can spend 90 minutes going over the extreme basics of so that you can write something that will tell you how much you should tip at a restaurant, and we will do that. But whether you feel like I know Python now is a different question. So to me, it's very helpful to target this kind of knowledge and to say what specifically it is that you want to learn how to do, because then that will also push you in the direction of what you need to, what specific parts of the language, and more importantly, what specific libraries, which are external things that you involve in the language that you need to learn. So it's kind of like, I want to learn Russian just to read Dostoevsky, people have said, I've heard. So, that means that there's a very limited kind of Russian that you need to learn. You don't need to learn any internet slang if your goal is to learn Russian to read Dostoevsky. So it's not the best analogy, but it works a little bit. And this is also because a lot of what we're going to be doing today is actually going to be very abstract problem solving. And if you take courses, so I'm actually doing the master's in the Data Science Institute right now. And so I'm taking like these grad level CS courses, which I never thought I would do in my life. And we're not doing anything in Python. Like, we're actually actively told to write our algorithms out in no real language. And that isn't, but that's because the important thing to learn is the steps you take to solve these problems. What those steps actually look like is often rather easy to figure out. The hard part is knowing the order of those steps and what those steps should be. Okay, so that's why this is a little bit idiosyncratic. What's this web page we're using? This is an interactive notebook. It's called a Google Colab or a Colab. I may call it those sorts of things. It is made up of, and you can edit it, it is made up of cells that are just blocks on top of each other. If you use something like Squarespace to build web pages, then you're already a little bit familiar with using blocks, or something like Squarespace. So if I click here, I see it changes the text, so I can see the preview here, and you can see the code that I wrote here. This code is written in Markdown. I'm not going to talk about what Markdown does, but you can sort of guess and see what it does here. So I can just say, hi everybody, and I'll make it big. And you can see it says hi everybody here. So that's text cells. You can also, let me close these. You can also have code cells. And the way you make a new cell is about midway here. If you move the mouse up, these two buttons will show up. And one is to add a code cell, and one is to add a text cell. A code cell is where you type in Python, and Python stuff happens. A text cell is these cells, where if you type in Markdown on one side and you get it rendered on the other side, and then when you click away, it looks pretty. Google Colab notebooks are based on Jupyter notebooks. The old version of these kinds of workshops involved with the first half hour of making sure everybody could get Jupyter to run on their computer. So that's why I use this, so I can spend that half hour, like, you can spend that half hour getting breakfast and whatever, and we can jump straight into getting you to code. And that's exactly what we do here. So the first thing to note is that in Colab, some code is comments. That means that it has the little octothorpe or hashtag or pound sign or tic-tac-toe thing, whatever you want to call it. If it has it in the front, then it's a comment. And Colab in day mode, I don't specify that here, but it's only true in day mode. In night mode, it's different, makes the comments green. So anything that looks green like this will be completely ignored by the Python interpreter. So this is a place where You can write notes to yourself when you're coding, and this is not unique to Colab. Like if you go on and start working on more complex Python projects that you have to do outside of a notebook, this will always be the case. Like it will be the case that you can use these comments. Regular code does not have the octothorpe. And this is the first line here. It says print, which is a function. And then inside the parentheses are what you want to print. And you'll note that the what gets printed is also surrounded by quotes. And I'll talk about that in a little bit. You can use single quotes, double quotes. It doesn't matter. And we'll see why you might want to use one or the other in a few minutes. So, OK, so but if this isn't doing anything, if you want the code to execute, you press this button that says play. Alternatively, and I will be doing this because I don't even notice that I'm doing this sort of thing, you can hit Shift Enter. And the first time you do Shift Enter, it'll give you this warning. You can say run anyway, and this happens. The reason it gives you that little warning, oh, it'll take a second. The reason it gives you that warning is because what Colab does is Google is effectively giving you a computer for a certain amount of time. Like they spin up a pretend computer, and you can see it has a certain amount of RAM. Oops. It has a certain amount of RAM, and it has a certain amount of hard drive space. And that computer exists somewhere in the cloud, in some data center somewhere, and is part of a bigger real computer. It's a pretend computer that's part of a bigger real computer. And you have access to this. And you can put data there. You can take data out of there. You can play in there. And in the meantime, that means that they give you an environment in which you can run code. And that's very helpful, because it means you don't have to install anything on your computer. OK, so I said print hello from a code cell. And then we saw this show up down here, hello from a code cell. I put a blank code cell here that you can try typing something in here. I'm saying hello to the women in STEM at SIPA group. And then I just hit Shift Return. And again, I do it automatically. I don't even notice it. Or you can press the play button, and it'll print it. And you can type in whatever you want. And I encourage you to try to print whatever you want. If you forget the quotes, something like that, you will see a little red bar shows up here. And that is an indication that this will probably crash. And if I hit play, it crashes. I won't be talking a lot about errors today, but yeah. So it has to be surrounded by quotes. And then it doesn't crash. So far, so good? Yes. Awesome. You are all now Python programmers. The next step is I'm going to very quickly talk about this workshop. There's no imports. Nothing is imported. Everything is completely native Python stuff. That changes in Module 2. In Module 2, we will import non-native Python libraries. So this is all native stuff, and these are sort of the fundamental building blocks of the language. These are things that exist in quote-unquote any language. And I will teach you specifically how to do these things in Python, but they exist in all languages, in all computer languages. They usually have the same names in all of the languages, except what Python calls lists are typically called arrays in other languages. And what Python calls dictionaries are typically called either hashes or objects in other languages. Other than that, numbers are numbers, strings are strings, booleans are booleans. So let's start with numbers. Numbers are numbers. So in Colab, it may be a little bit tricky. It's hard for me to see this today, but they're green also. This is a Colab thing. Colab will color numbers in green. And they work sort of like you expect. If you say print 7 star 6, that's print 7 times 6. Oh, how come it has all these things evaluated already? Oh, well. If you change that, I'll change it from 7 times 6 to 7 times 7. hit shift return, and we get 49. Star is multiply, slash is divide, so 7/7 is 1.0. Python distinguishes between integers and non-integers, which are called floats, but you can generally use them pretty interchangeably. Python is not, no computer language is actually really good at doing math, which is perhaps surprising. But computers tend to be computers fudge a lot of stuff and in order to get things happening, because the computer ultimately breaks everything down to binary, and binary is very bad at doing things like talking about thirds. Like, how do you represent 1/3 if the only numbers you can use are ones and zeros? It's impossible. So it fudges things. So this is why for financial computing and stuff, there are special libraries that make sure that these, like, one thing that they do, for example, for financial computing is they multiply everything by 100, so there are no cents. Because it's okay if the fractional amount of a cent is wrong, but if the actual number of cents is wrong, then problems can happen. And if you're talking in terms of dollars, then it's possible that you will be like 1 cent off. And those issues can accumulate. I'll slow down a little bit because I see both Dan and Madiha are busy. Oh, Madiha has a meeting. Okay. What? No. Everything. I just don't want. I want to give people who are having trouble an opportunity to have their issues. Go ahead.
First, one thing I observed is those of you on a Windows you have to click work in Colab to open the Colab notebook.
What does that mean? Work in Colab.
Like, there's a link at the top in the corner of the on the GitHub page that you.
Yes.
Yeah, so it
You have to.
Colab, so you have to click that.
Yes. Sorry, I did that rather quickly. You all have to click on this link. This won't work. This has not this. Yeah, this won't work no matter what happens. And I'm a little bit confused why it's half filled in, but I don't. That's nothing, neither here nor there. But yes, I don't think GitHub lets you run notebooks inside of GitHub. If they do, that would be great. But that's also expensive because, as you saw, running these notebooks means making a fake little computer and letting you use it. GitHub is owned by Microsoft, so they have the money to do this sort of stuff, but we use Google instead. So, okay. Back to the notebook. So this is the first cell that you actually have to run because each cell that we've executed so far runs in isolation. Like, we're not doing anything fancy here. We're just doing print 7 divided by 7, or whatever it was originally, 7 times 6, I think. 7 times 6. That's just, it's just one command, nothing happens, nothing is set, we move on. But starting with this cell, we are going to start creating circumstances that persist through the notebook that we can, because we're going to start using variables and we're going to start assigning values to those variables. So the way you assign a variable in Python is you think of a name. The idiomatic Python way to do this is to call your variable something with underscores in between it, like my underscore number equals 7. And then if you do print my number times 3, you get 7 times 3, which is 21. So you can name these variables anything you want. You will see in this workshop that my variable names are often hilariously detailed. And that is just because that's not a bad thing to do, because you want to know what your variable is doing. It's very easy and very common to just name variables one letter, which is fine. You can do that if you want, but you can also have useful names that if someone else has to look at your code, they know what your intent is. Because broadcasting intent is one of the most important things you can do as a programmer who shares their code with someone else. It works is great until it doesn't work, because when it doesn't work, then people have to go see why it doesn't work. And if they see a whole bunch of things that are just one letter, it's going to be hard for them to figure out what is doing what. And it's going to be difficult for them to understand your intent. That's why comments exist. So you can say, here I am doing XYZ. I guess XYZ are just one letter. Yes?
Can you name a variable with spaces in between?
I'm pretty sure you can't, but we can try it.
I did.
And it says invalid syntax, so you cannot name a variable with spaces between. That's why we have the convention of using the underscore. I also think you can't use a hyphen. Yes, you cannot use a hyphen either. It thinks a hyphen is a minus sign. Yes?
There is no specific command for creating variables, just name the variable and what it should be.
Yes, the command is the equals sign. So Python is very forgiving in this way. You don't have to be like declare variable or something like that. You just type something in, and Python will automatically, I think this is about right, Python will automatically initialize that, and then the equals sign is an operator that comes afterwards. It's the assignment operator, and then that means that whatever is on the right-hand side of the equals sign gets assigned to the variable that gets initialized as soon as you type it. The reason this works is because Python is a interpreted language, so it reads the code and tries to figure out what you're trying to do, and then it executes it. And when it can't figure out what you're trying to do because there's a hyphen, then it'll give you an error. Excellent. Thank you for the questions. Please do keep asking them. Okay, so the reason I brought this up about variables and about state that persists throughout the notebook is because we define my number here, and we have access to it in another cell. The cells don't have to be in order. Because I can create a cell above the cell where I defined it, but this cell has to be played before this cell. So it's a little bit confusing. In observable notebooks, which are written in JavaScript, then you can have them in any order, and you can play them in any order because of the way that it handles state. But I think, why is this brown? It's probably, this brown probably means you are using a variable before it is defined. I don't know why it's giving that error. Anyway, so that's numbers. Yes?
What's the value add of creating a variable like my number versus like?
You'll see, the initial value add is just to show that you can encode information in something that is, yes, typing my underscore number is a bigger pain than typing 7. But unlike in algebra, where x always only has one value, like effectively, here the variable value can change over time. And so you can do, but that's actually, I'll show an example of that right now. My number equals my number plus 2, plus 1, plus 2. Like, this makes no sense in algebra. This can't be true. I'm pretty sure it can't be true. Like, this goes against the axioms of real numbers, blah, blah, blah. Yes?
I realized like I changed the name of the variable, but if you don't, like the below command where it's like print like the new variable plus 2, it's still running the mathematical order, right, even though the names are off.
Yes, so if you change, so if you set my underscore number and press play, then my underscore number is written into the memory of the system. So if you change that cell and change my underscore number to my underscore awesome underscore number and press play, you will now have two variables, my underscore number and my underscore awesome underscore number. And you will be able to call whichever of those.
Oh, okay.
Yeah, so actually there's a way to see this, this little X here in the braces, shows you all of the currently available variables. So even though you change the name of, you change the name in the cell and reran it, if you click on this X, you should still see my number here. And I think, and there's a, if I sort of hover the mouse over it, it'll tell me the value of my number.
Oh yeah, they're all the same. That's confusing.
They're all the same, yes. You'll see that things are less sloppy quickly, but for now we can afford to be sloppy because we're learning the basics. Anyway, like I said, this makes no sense, yet it works. And then if I create a new cell and do print my number, it says 9. So this is why you don't just use actual literal numbers. In fact, there's a strong disinclination to ever using numbers. You define all your numbers at the beginning, and then you only work with variables throughout. Because let's say, for example, you have a somewhat complicated program that relies on the fact that a certain class is 6 credits, right? So imagine that you just wrote a 6 in all of these calculations about that class, right? And then all of a sudden that class is reclassified as being 3 credits. So now you have to go find every single instance of 6 in your code and figure out if that 6 refers to the amount of credits of that class, and if so, change it to 3. So it's much better to just say class credits equals 6 at the top and use class credits all the way through the code. So when it goes from 6 to 3, you just have to change it once, and it flows through the rest of the code. Okay, so strings are read in Colab. Strings are text, basically. You surround them in quotes. Like I said, it can be double quotes or single quotes. We've already used strings because print, quote, quote, hello, how are you, whatever we typed at the beginning there, that was a string. And you can assign a string to a variable, like my string. And then you get sometimes slightly odd results because you can actually multiply a string. And what happens is you get 3 instances of the string. What happened here with my string plus 2?
The 2 is in quotes, so it says.
Yeah, the 2 is in quotes, so it just gets added to the end. What if I get rid of the quotes? What do you think will happen? Well, I mean, I'll tell you, it'll crash. It'll crash because, adding the number 2 to a string doesn't really make sense. But if you surround the 2 in quotes, then it's actually no longer a number. It's now a string, so this does work. This is a little bit dangerous, but because Python can sometimes see the string 2 and still interpret it as a number. Sometimes you have to be explicit about that, but sometimes you don't. It can be a little bit risky. This is, Python is not by default a strongly typed language, so the interpreter makes guesses about whether something is a number or a string on the fly, and doesn't particularly care until it can't decide, and then it crashes. Well, it gives you a warning. Well, it crashes while telling you why it crashed. I just want to make it sound, crashing is not a big deal. Like, it happens all the time. It's not like your computer crashing where you're like, oh, my work. Yes?
How do you add space so that it says hello, how are you, space, emoji, space, hello, how are you? You just add the space
You want,
quotation marks?
yes, so you can add a space here. And so now it adds the spaces. But now there's also, like, you can't see it, but there's an implicit space at the end here. If you want to, you can do it so that it doesn't have this last space, but it requires a little bit of cleverness that we'll sort of see as we move on. But yeah, you can just add, spaces matter. And Python is actually, we'll see this in a few minutes, Python is actually one of the few languages where spacing really matters, in the code even. With a lot of, with a lot of programming languages, you can just, it can all just be one giant chunk of letters and symbols and stuff with no spaces and run perfectly fine. Python does not do that. Python requires you to have spaces for certain things. And we'll see that stuff in a second. Yes?
So you can space strings, but not variable. Is variable names the only thing you can space?
Effectively, yes. So you can put spaces inside of strings because it's inside the string. Like, the string doesn't care. The string is just a collection of different alphanumeric symbols, and a space is an alphanumeric symbol. So a space is no different from the letter A in that case. You will run into difficult, like, spaces aren't that tricky for strings. Carriage returns are much trickier. Tabs are trickier. We'll see by the end of this first module, we'll see how you can encode carriage returns or new lines into strings. Like, we'll see it because it's just in the example that I use, but yeah. So, okay. As of a few years ago, Python now has F strings. And F strings, I don't know if this is true, but I guess the F stands for format. And what F strings let you do is let you create a string that has Python code inside of it that is evaluated inside the string. So this is perhaps a little bit abstract, so seeing it may work better. So in the first line of code here, I create a variable, my name. I assign it the value moisir, which is because that's my name. If you do the same thing, you're lying, so you should put your name in there. And then I write my greeting is F hello, comma, my name in braces. And then I do my non-F string greeting is just hello, comma, my name in braces also, but it doesn't have the F in the beginning. And then when I say print my greeting, it says hello, moisir, right? And when I say print my non-F string greeting, it says hello, my name in braces. Now you see this string, hello, my name in braces, these are identical, completely identical. You have a quote, you have the word hello, comma, space, brace, my name, close brace, quote, close quote, completely identical. But when I print them, I get two different results. And that's because of this F. And Colab colors them a little bit differently too. But you can see, like, when I highlight it, it highlights right below it too, because Colab understands that these are identical. Like, the characters are identical, but the functionality is different. Because of the F, when we have this brace, that brace signals do Python inside of these braces. And the do Python is evaluate the variable my name. Whoops. So I can similarly do hello 4 times some big number. And if I press play, then I just get the result of that math operation inside there.
It didn't.
It didn't work for you?
So it did, but I still don't get.
How it works?
Yeah.
So
What's the
what's the difference? Well, this is just a regular string. It is literally just what's inside the quotes. When you add the F, it's no longer literally just what's inside the quotes, because the braces are like a code word, a little trigger that say what's inside this braces is not literally what I'm typing inside this braces. It's a tiny little chunk of Python code.
But it could be whatever.
It could be whatever.
For example.
What's that?
It could be whatever letter or only the F.
Oh, no, it has to be an F at the beginning. Sorry, that's why these are called F strings, is because if you start with the letter F, it lets you do these kinds of things. Yes?
I'm trying to understand why anyone would use my non-F string greeting. What purpose does it serve?
Well, it's obvious, it's a contrived example. It's just to show the difference between these things, but if you don't need to interpolate anything into the string, then you just use the literal string. Dan?
It's for formatting, basically. So it's a way for you to control exactly what the output is, but include code or variables when need be. So F stands for format, and I could be wrong with that, but basically think of it as like a formatting string. So otherwise, you're kind of stuck with like going in and out of your strings to your variables, adding pluses or commas, like it's a little messy. This would allow you to, let's say, exactly format something the way you want, so the output looks like how you want, which is not necessarily as important here, but it is if you're making a document or
Yeah, we'll see.
or anything like that. So F strings are formatting.
Right. We'll see a little bit of that, because by the end of this we'll be writing by the end of this module we'll be writing form emails to our professors. And unless you plan on just writing dear professor, if you want to say dear professor blah blah blah, then you would use an F string where in the blah 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 you put in their last name, right? And but the non-F string greeting is because sometimes you don't need to put extra data in. Like it's okay to have just the string as itself. So this is contrived in the sense that you will probably never type a string with braces that say my underscore name in it. So that's the contrivance. What Dan was talking about is just quickly is yes, this is the old way of having to do this sort of thing. Doing something like this. This lets me, with an F string, instead I can just put my name in braces inside of one larger string. It's a question, and there are other ways to do this in Python too, and there are ways to do it to format the numbers and everything, but F strings are the extent of how much detail we'll be getting into this today. Yes?
Over here we assign my name just one value. Like say you're trying to work with the mailing list, can you assign multiple to the variables?
Yes, we will see that by the end of this module. That's in 2 or 3 steps. Okay, so far so good. A lot of this is great because you're already starting to see sort of the edges of these sorts of things, and that's important because it shows that like the worst thing in the world for these things is just press play, and then you're like, I'm done. Now I know Python. But you're actually like thinking about this sort of stuff and playing with it and trying to break it and so on. Okay, Booleans are the next type. So we have numbers, strings, Booleans. Booleans are easy, true, false. That's it. Capitalization matters. So it's capital T and capital F. No quotes. You just write them bare in the code. So you will not often write them. We'll see over the course of the day there are places where I do if blah 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 equals true. But this is what they look like. They're capital T, capital F. Now, what Booleans do is what you can do in Python is write a test. And a test is a statement that returns the value true or false. The most common type of test is the annoyingly written double equals. So 1 equals is the assignment operator. My name equals hors-série, means there's a variable called my name that has the value of that string, hors-série. My name double equals hors-série is a test. Is it the case that the variable my name equals the string hors-série? If yes, true. If not, false. So we have here, in this example, my number is my number with an F string. So that prints out this. So this lets us know that my number is 7. And actually, if I do this again, because I renamed my number to 9, so it now says my number is 9. I did that back up earlier when I did my number equals my number plus 2. So my number is equal to 9. Is my number equal to 2? So now you can see this test here. My number double equals 2. Well, we know my number is 9, so this is false. So it prints the result of this test, because this is executing Python code. So let me create a little. So if I do my number equals 2 and run that, I get false. So it's doing the same thing here. That little test, it's doing up here, and the answer is false, so it prints false. What's that? Okay. Yes?
What do these different types of quotation marks next to my numbers mean? Like I see that there are different kind of quotes.
I'm not 100% sure why I did that. I mean, so the short answer is because that little backtick is what in Markdown formats text as code. So if this were in Markdown, so I can show that really quickly. My number versus my number. So you can see this looks like regular text, and this looks a little bit different. It's printed in a monospace font and has that little background. I just use it here. It's not a bad idea to, when you're talking about specific variable names, specific function names, to put them in code font so that it's clear that, I mean, this is a style thing. If you look at most programming books, in the introduction, will have a page about what the different typefaces mean. And among them are to distinguish between, to show that this is something like code. But it doesn't actually mean anything here because strings don't care. It's just a backtick and then blah, 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 and then another backtick. But that's why I did it. Yes?
If you were to use, I don't know how to do the backtick, but if you were just to use a single quotation mark, would it achieve the same outcome?
Basically, if you have your strings in a double, you can use single in them. And if you have them as single, find the string, you use double in them. Okay. So an easy way is if you wanted to use a single quotation mark in it, you would need to say you need to use double quotation marks around the string, and vice versa. So you can't really use one or the other without escaping it. And
the third line here, it addresses that specific version of the question. If you want to use single quotes instead of backticks, go ahead. It doesn't matter for these purposes.
There is a follow-up question. How do I get a backtick on it? Is it a special character?
If you're on a Mac, it's just the key right below the escape, and I think maybe that's the case on a Windows machine too. But yeah. So this test is this arrow-looking thing means less than or equal to. 1 second. Sorry. So this means less than or equal to, so it says true, because my number is 9. Is my number less than or equal to 100? Yes, print true. Now here's the question about the quotes. For this one, I write, let me press play on this again. Is my number equal to double quote a number, double quote, question mark? My number equals double quote a number, double quote, close brace, single quote. Why did I switch to single quotes here? Because I wanted double quotes inside the string. So if you have a string with double quotes on the two sides, and you put a double quote in the middle, the parser is going to be like, I don't know what's going on here. This is where a string should end, but it doesn't start, I don't know, and it just crashes. So ways to get around that, the easiest, like most ergonomic, I think, way of getting around that is you use a single quote instead if you want to use double quotes inside the code, or the opposite. So that's why I personally prefer to always use double quotes so that I'm never confused why something is breaking, because I always know that I started with a double quote, so if I need to use a quote inside the double quotes, I know it has to be a single quote. If for some reason you are in a situation where you absolutely need to have double quotes on the outside and you need a double quote on the inside, then like Dan said, you can escape it. And an example of that is I can just do print, I am escaping, and I just escaped. So escaping is you type backslash, then a quote. Then that means the backslash says the following quote doesn't mean the end of a string, it's just a double quote. And you'll see this structure a couple times today. Backslash something. What's that?
Can you repeat that, sorry? What the backslash meant?
The backslash means the next character is not, like, treat the next character a little bit differently. So backslash double quote means this next character is a double quote, but it does not mean the end of the string. So just treat it as a regular double quote inside a string that is delimited by double quotes, or delineated. Yes, go ahead. Sorry.
So it's going to print the double quotes like that.
Uh-huh.
And then what if we want to print another one after escaped? Would I just do another backslash? And okay.
Yeah, just like that. Every time you do a backslash double quote, it just means like, this doesn't mean the end of the string. There are, and we'll have other examples of that in a couple minutes. Any other questions? Yes?
To
Sorry,
denote
go ahead.
a string, then I can use either the single or the double quote.
Say that again?
To denote a string anywhere, I can use either a single quote or a double quote?
The beginning and end have to be the same thing.
But it can be either.
It can be either,
Oh.
yes. There is, I'm pretty sure in Python there's no actual benefit to doing one or the other. I just recommend that you are consistent, because if you are consistent, it will help you find problems more easily. And perhaps it's unnecessarily complex that they give you this many different ways of doing these sorts of things, but that's the language that we've inherited. Okay, so that's Booleans. True, false, with the tests. We will see many, many tests today, because handling conditionals, if this, do this, else do this, is a central component of doing any kind of real problem solving, right? Okay, now things get actually complicated. So, but in a great way. Functions are where things happen. Functions are kind of the verbs. So far we've been dealing with nouns more or less, I guess. But functions are the do stuff to stuff. We've seen one function already, print. And the general look of a function is it's going to be some kind of word or words with underscores, and then with parentheses. Like we have print, parentheses, something inside of the parentheses. And that means print whatever is inside the parentheses. If it's a variable, print the value of that variable. If it's a math statement, print the answer, the result of that math statement. What goes inside the parentheses is can be variously called the parameters or the arguments, and we'll see those in a little bit. And functions are also where spacing really starts to matter. I said earlier that spaces don't matter in strings because a space is a letter, is a hyphen. They're all just alphanumeric characters. Well, I guess a space isn't actually alphanumeric, but just, alphanumeric plus. And the string doesn't care. It doesn't break, a space doesn't break anything inside a string. But spaces do break things inside of Python. So I'm just going to press play, and then I'm going to explain what's going on here. So the first line is a familiar looking line. Print my name is len my name letters long. Len is your second function that you're learning today. You've learned print already. Len takes the length of whatever is inside of it. Not everything has a length. A number doesn't have a length. That doesn't make any sense. What is the length of 4? But a string does have a length. What is the length of my name? It's however many letters long my name is. And we'll see other things have lengths too. And it's often vitally important to be able to know how to get the length of something, or to make a decision about something based on its length. So it says my name is 6 letters long because M-O-A-C-I-R is 6 letters. Okay? Now, the second part defines a function. The syntax for defining functions in Python is def, like define, space, then the name of the function. In this case, it's called how long is a word. You can name your functions whatever you want. You can name them one letter if you want. Don't do that, but you can. So the name of this function is how long is a word, and then parentheses, and then word. And what this means is that whenever someone executes this function, whatever they put in the parentheses, I'm expecting them to put one thing in the parentheses, and then I have access to that, or the function has access to that one thing as the variable called word. That variable can be called anything you want, but it's helpful to use variables that make sense. I can call this how long is a word chocolate. And as long as I change chocolate here and here, it will still work because the variable name is arbitrary. But what it means is that whatever I pass into the function, and that's the last line here that we'll see in a second, whatever I pass to the function becomes available inside the function as this variable name.
But chocolate isn't 6 words long, 6 letters long.
You're right. I'll explain that in a second.
Okay.
No, it's true, but neither is word. Word is only 4 letters long, and that was what was there before. So the last part of the first line, so it's define function name parentheses with whatever the parameter or parameters are, and then colon. The next line has to be indented. Has to be indented. This is Python's rules. How much it's indented doesn't actually matter. I think by default, Colab will indent it 4 lines. These are arguments that programmers have. I always indent 2 lines. It actually doesn't matter, but it has to be indented, and it has to be consistent for the extent of that block. When the indent level changes from 0 to 2, or 2 to 4, or 2 to 3, that means that there's a new block. And if Python sees from the indentation that there should be a new block, but it hasn't been triggered in some way, like with a colon, it will crash. It will say the indents aren't right here. So it has to be consistent, which is why something like Colab, as soon as you type the colon and hit return, it will automatically indent the next line, because it knows that you're doing something inside of something else. And that insideness is demonstrated by indenting in Python. In other languages, it's demonstrated in other ways, like with parentheses or braces or something. In Python, it's indentation. So it's very common to have indentation, to have errors that say something about indentation. Okay, Now this function is all of these things are toys. All this function does is it prints, oh, I have to speed up a little bit. All this function does is print your word, chocolate, is length chocolate letters long. Now, yes, chocolate is not 6 words long, and that's because chocolate is an arbitrary word that I chose to name that variable. When I call the function, how long is a word, I am passing in a string, a word, which is A space W-O-R-D, 6 letters long. So that's where that 6 comes from. It's because of the string that I'm passing in. If I pass in the number 4, it's going to crash because the object int has no length. Oops, that's still crashing. But if I just put in word, oops, too many quotes, it's 4 letters long. Yes?
Yeah, can you just repeat the relationship between the print command and the one below that?
So this def, this is me defining a function, right? We'll see this throughout today. I'm defining a function that does something. In this case, it does the very uninteresting thing of printing a line of text that prints your word, then that line of text is, and then how many letters long it is, and then letters long. And the way we trigger that, the way we have it do that, is by calling it. That's the technical term for it. We call the function here.
Yeah, I guess, sorry, my confusion was, so chocolate, is that a variable name or can
Correct.
Oh, it's a variable.
Yes, it's a variable name. So if I type in how long is Butler Library, and then breakfast, I am executing this function 3 times, each time with a different, chocolate has a different value each time. The first time the value of chocolate is word, the second time the value of chocolate is Butler Library, and the third time the value is breakfast. And that's why we get 3 different answers here, word, Butler Library, breakfast, and 3 different answers for how many letters long it is. Okay, a typical example of a first function is to write something that creates a tip, that calculates your tip. I don't think that there's stuff here that we won't have to really worry about, but this works on the same premise. Is you have the if statement, and an if statement also needs indents. If something, colon, indent, do stuff, pull the indent back, else, colon, indent again, do other stuff. So this is if good service equals true, the total with tip is 1.2 times the total. If the good service is not true, the total with tip is 1.18 times the total. And if you run it, we have these 3 different options on a $20 bill. And we get different values and what you owe. That I leave as an exercise to later because I absolutely have to get through lists and dictionaries. Lists are collections of things, and they are surrounded by brackets. So we so far see that you can surround things by parentheses, like if there are arguments to a function. You can surround things with single or double quotes if you're creating a string. If you are surrounding things with brackets, that is a list. A list is a collection of things that is comma separated, and it can be as long as you want, and it can be any different kinds of things. In other languages, lists are called arrays, and in some other languages, they have to be all of one thing. You can only have numbers or something. And Python doesn't care. Python will let you put anything in here. So this list, my list, the first thing is a variable pointing to my name, so Moisir. Then the number 2, then the string tree, then the number 82.4, which is a float, not an integer, whereas 2 is an integer. I can also have my list of numbers that is just numbers. Python doesn't care. The most important first thing to learn about lists is that the way you access a member of a list is using the bracket operator. So you use brackets to define a list. My list equals bracket, blah, 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 close bracket. And then if you want a certain member of the list, you pass in what's called its index, which is its place in the list, inside of brackets. Now, Python is what's called a zero-indexed list, which means that the first value, the first index value is always 0. So this is why I say the 0th value, the 1th value, the 2th value, the 3rd value, because to distinguish between first, second, and third. Because the first element in the list is actually the 0th value, because its index is 0. So the second member of the list is the 1th member of the list, because its index is 1. The third is the 2th, because its index is 2. So you can see that here, my list 0 prints the 0th member of the list, which is my name, which it evaluates to moisir, so that's why it prints moisir. Python gives this little bit of candy where -1 is the last member of the list. So when I do print my list of numbers -1, it prints the last member of the list, no matter how long the list is. -1 is always the last one. So far, so good? Excellent. Lists have lengths. That is probably obvious. You can do len mylist, and we'll tell you how long the list is. The great thing about lists is you can iterate over them. You can move over them and do things with them. There are a handful of ways to do this. Probably they get more idiomatic, but it's also complicated because this requires, and this I have to do slowly because this is the first real big step, I think, in terms of learning how to do any kind of programming. If you understand how this works, nothing will confuse you. Getting to the point where you understand how this works takes a little bit of time. So it makes sense that it takes time. So to iterate over a list, here we will use something called a for loop. And the for loop takes the syntax, it's made up of 5 parts. The word for, then an arbitrary name, an arbitrary variable name. Then in, it's always the word in, and then the list name, my list of numbers. Or the list, literally, some kind of list. And then colon. And then if there's a colon, you know the next line needs to be indented, and the indent is do something. Now if I press, so we have this my list of numbers is these numbers 3, 5, 2, blah, blah, blah. And then if I do for element in my list of numbers, print element times 2.1, and I get these answers. The element thing is what is tricky, or I have found is tricky to people, to understand what on earth element is here. Element is an arbitrary variable that represents the current member of the list that I am iterating over. So the first time I go through the loop, element refers to the 0th member of the list, which is 3. The second time I go through the loop, element refers to the 1th member of the list, which is 5. The next time, element refers to 2. The next time, element refers to 8. I think using element times 2.1 is maybe a little bit, this is used to demonstrate how Python is bad at math, because how on earth what is 3 times 2.1? 6.3. Yet Python says it's 6.3000001. When I taught this to undergrads, they were like, well, maybe computers are just more precise. No, it's 6.3. This is the computer is making the mistake. So, but this is maybe not the most helpful thing. It might be, what did I do wrong here? Oh, I never press played here. Doing multiplying by 2 may be a little bit less abstract. So the first time through, element is 3. So it prints 3 times 2, 6. The next time, 5. 5 times 2 is 10. The next time, 2. 2 times 2 is 4. The next time, 8. 8 times 2 is 16. The next time, 29. 29 times 2 is 58. That sounds right. And then the last time, it's 3.2. Yes?
Okay, so element is telling Python to go through each one of the elements. That's
The entire line for element in my list of numbers, colon, that entire line says loop through this list. Element is the arbitrary name that I've chosen that refers to that member of that list at that specific time that it's doing the loop. So I can change element to anything because it's just a variable name. I just have to be consistent. But like, this is again why this is another version of why variables are important and why variables in programming are extremely powerful, is because they can hold temporary values that let you do things like go through a list and use the same variable, I, in this case, or element earlier, use the same variable and just constantly have new values for it. But you notice I never do I equals anything. There is no I equals. Yet somehow when I do print I times 2, I get these values. Because I is set inside this loop. For I in my list of numbers, colon means for every element in this list, do this sort of thing. I'll type this again. This might be a little bit clearer for n in 1, 2, 3, 4. Print n times 2. So you can kind of see what's happening here is that the first time, so it goes through the loop. N is 1, then n is 2, then n is 3, then n is 4. And so it's 1 times 2, then 2 times 2, then 3 times 2, then 4 times 2, which is what we get here. This is tricky, I think, or it has been my experience that a lot of people have difficulty with this. But the important thing is that you are looping over a collection of things. Python has this sort of cute syntax called a list comprehension, which is a loop that's just described a little bit more tersely. I don't want to spend any time on it, but you will see these because I think they sneak into the code. But it's the same thing except it's all in one line. So this list comprehension lets you square all the numbers. Okay, dictionaries. Last part, most important part, which is why we have 3 minutes. Dictionaries, oh, I meant to delete this. Well, it doesn't, it's too late now. Dictionaries are delineated by braces. So quotes and double quotes delineate strings. Parentheses delineate the arguments of a function. Parentheses also do other things, but for now we only know that they delineate the beginning and end of the arguments to a function. Brackets delineate lists, or also there's the bracket operator to access a specific member of a list, like with the 0, the 1, et cetera, et cetera. Braces delineate the beginning and the end of an object, or of a dictionary. Dictionaries are like lists. They're sort of like lists in the sense that they are a collection of things, but each thing has a name. So there's a key, the name is the key. So there's a key and then there's a value associated with it. So whereas in this list, for example, where was it? In this list, the index is 0 and the value, let me not use numbers because the index is 0, the index for B is 1, the index for C is 2, and the index for D is 3. In a dictionary, the index can be something more useful than a number. So I picked 4 professors at SIPA and created dictionaries for all of them. So we can start with the first one. We have a variable called mits equals open brace to start the object. Then this object, this dictionary, has 4 properties, 4 keys. You can use, these terms are used somewhat interchangeably. I don't know what they're exactly called in Python. Keys, properties, whatever, but it has 4 of them. The first one is called name. So double quote name, double quote colon, and not equals colon. And the value of the name property is Tamar Mitz. Then comma. The next property is title, in quotes, colon. Then in quotes, assistant professor of international public affairs. Oh, I wanted to add let's do this way. Okay. And then areas is the third property that's a list. And it just happens to be blank because Tamar Mitz's webpage does not list any areas of interest. So I didn't want to make anything up. On leave is a Boolean, true. The point being here is that you can put anything you want as the value. The key, stick to strings. To the point where I don't know if you can use non-strings because I can't, no, stick to strings. But the value can be whatever. And the value can be a string, Tamar Mitz. It can be a list that happens to be blank here. It can be a Boolean, true, or it can be a number, advisees. If anyone sees this, I made up the advisees numbers. This does not mean that Tamar Mitz only has 3 advisees. Yes?
So is a dictionary a list of lists? Like here in this
It can be, but that's what you have here. Let's look at this areas where it's actually a list with elements.
Yeah.
Areas is a property whose a key or a property whose value is a list. So you can make a list of lists just by typing brackets inside of brackets inside of brackets. The value with a dictionary is that you don't have to rely on the order of things, you can rely on the names of things. So you can access things more easily that way. It's a good way to think of a dictionary is the name is tricky, but you can think of it as a word and then the definition, or you can think of it as something like a driver's license, where you have name, blah, 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 date of birth, blah, 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 height, blah, 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 organ donor, true, false, and photo, blah, 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 URL to photo, something like that.
So lists are strictly ordered, but dictionary goes by names.
Exactly. Dictionaries are ordered too. I always say this. They are ordered in a consistent but unpredictable fashion. So you should not rely. If you create the same dictionary a bunch of times, internally the keys will always be in the same order, but it may be different. You don't rely on that. That's the point. Is that instead of relying on the order of things, you rely on the names of the things. Yes.
Is the fact that name, title, areas are all in double quotes just like syntax?
Are
those variables?
You'll see in a second. You'll see in a second why I set this up this way. But what I'm trying to show is that whereas in a list, like that list above effectively looks something like this. Again, I don't even know if this is going to work. It was A and B. I changed it. So the list that I created up here, wherever it was here, it's not entirely wrong to think of it as a dictionary with these as the keys, 0, 1, 2, 3. You'll see that the syntax looks very similar. We'll see all this in a second. And in fact, I think Python actually defines lists as dictionaries like this, which is wild, but we use the names because the names make it easier for us to think about these sorts of things. It is the case sometimes that you will get a data set where it's just like, oh yeah, the fourth value in the list is the date of birth. Here, instead of relying on that, we actually name something date of birth, something like that. Okay, so I created these 4 things. They all have different areas, titles, names, etc. And then I put all of the 4 variables into a list called faculty. Now, we can iterate over it. So for professor and faculty, print professor name is professor title. And so this is I think what you were asking earlier. So if this were a list, we would have to do like print professor : 0, because the name is the first property that we define. But it actually isn't, because the way they do the math, like I said, it's consistent but unpredictable. So you don't use the numbers, you just use the key, which is name in this case. So you do professor name is professor title. And you see you get this printed out. So it loops over all 4 faculty members, and it prints out their name and their title. Yes?
Do we define professor?
No. This is the tricky thing about lists, about for loops. This is what I mean, that the for loop, the word for and in, those have to be there, and the colon has to be there. So of 5 parts, 3 are always there, and they're always the same. 2 of them are whatever. The second of those 2 things is effectively a list. It has to be a list. So we created this list called faculty up here. But professor, you're right. I never did professor equals anything. But this is what is happening abstractly in the background with a for loop. Is when I say for professor in faculty, what that means is that take the list faculty, loop over it. And every time you loop over it, whatever is the value of faculty at that time, create a variable that's only available inside this loop, so only inside this indentation, and print and do something with it. So if I just do print professor at the end, it's going to crash, or it should. I don't know, that shouldn't have worked.
So you could replace professor with anything because it's the same as element. You just replace it with element.
Exactly correct. I just picked professor because it's expressive. It describes what I'm working with here. I don't know why this isn't crashing. This really should be crashing, but
I think if you remove the statement above and then print just professor, that will crash.
Yeah.
But because you're probably
Yeah,
saying professor name and then professor title, that's why it's not crashing.
perhaps I think maybe the state does carry over. It's not predictable. It should. This is a scoping question. I've never tried this. I'm honestly surprised this works. It should not work. In JavaScript, this would not work. Like in every other language I know, it would absolutely not work. You could not create a loop and use the iterable variable inside the loop outside of scope. It would not work. But here it seems to work.
You can do it because the last professor is still a variable. It's just once it ends, professor is still there.
Yeah, but
Yeah, no, but I'm just saying, like, it's just the last element of that list. The variable professor
Right.
is still there. So even outside of the loop, it still exists.
I should be outside of scope, and I should not have access to variables that are inside it's a scope question. But I don't know how scope. Okay. We're not going to talk about scope anymore today. So we have another loop here for professor and faculty. If professor on leave is equal to false, print their name. So now we can see which 2 professors are not on leave of the 4 that we have. We can do this even terser with 1 line. Print blah, 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 blah. This is the same exact thing, except it actually prints a list instead of 2 separate lines of text. And then we can start putting together like search terms. Like you can sort of think of this as search terms. So for professor and faculty, so start the loop. Works on data equals 0. So this is a variable that I create that I just set to 0. Then for interest in professor area, in professor areas. So remember, areas is a list inside of each professor. So for interest in professor areas, so I'm doing a loop inside of a loop. So now in areas, loop through all the different interests they have, and then if data in interest or capital D data in interest, which is the Python way of saying if this string appears in a string, let me show an example of that. BA in ABBA, true, because the string BA appears inside the string ABBA. If I change it to AB, this should not work, false, because the string AB, little a, B, does not show up in the string ABBA. If this is a capital A, yes? If this is a capital A, it will work. Okay, so that's why I have data and data. There are ways to do this that are more ergonomic, but I just wrote it up this way. So if the word data with a little d or the word data with a big D shows up in interest, set works on data equals to 1. Then, if works on data, after it's done looping through all the interests, if at some point it has taken works on data and changed it from 0 to 1, then do the rest of this stuff. If works on data is equal to 1, set leave status to is not. Then if professor is on leave is true, set leave status to is. So go from is not to is. Because then if works on data equals 1, we can track the indentation here. The last thing here is print professor name, works on data, and leave status on leave this year. And we get Sharon O'Halloran works on data and is on leave this year. Yes? So what I'm interested in doing is I want to find out all of the professors who work on data. And the way I'm going to do that is to check to see if the word data shows up in their interests, right? So what I do is at the beginning, I assume that the professor doesn't work on data. That's my null hypothesis, right? So I say works on data equals 0. Then I loop through their interests. And if I find that one of their interests does have the word data in it, then I change works on data from 0 to 1. And so then I know that if works on data is now equal to 1, that means they work on data. So I can do the rest of this stuff. So you know, there are 4 professors here, but only 3 show up here because one of them doesn't work on data. Because Tamar Mitz has empty areas of interest. So whether she works on data or not, I don't know. It's not in the thing. so she does not print in that thing because for her, when I'm looping through this and it comes time to do Tamar Mitz, works on data stays 0. It never gets changed to 1. So this whole if statement never happens. And her name never gets printed. Okay? And then I think this is the last thing, yeah. So we'll be done. We're not that 15 minutes behind schedule. We can write letters to faculty. So works on data, again, 0 for interest in professor areas. So again, as above, figure out if they work on data. And then if they work on data and they are not on leave, set the last name. I'm going to skip this because we'll talk about splits and this sort of stuff in the next module. But you end up with this string that prints these two emails. Dear Professor Martinez Restrepo, I'm a very good student and want to learn data, thank you. And Dear Professor Oliver, I'm a very good student and want to learn data, thank you. And that's it. So from this collection of stuff here, and this little bit of code, oops, not that little bit of code, this little bit of code, we get these little emails that we can send. I mean, this is obviously a ridiculous toy example, but the expressivity and the like combining together these different little mini problems and these mini little solutions to get, you know, a mail merge. That's not nothing. You know, it's kind of cool. Yes?
The \n is for space.
Great question. So remember how I said \quote to escape the double quote? \n is the new line character. So \n is how we get this double return. This one and this one. And \t I think is tab, et cetera, et cetera. So if you, you will very often see this \n accidentally in bad websites. Because this is a standard. This is not a Python thing. This is standard throughout many languages. Okay, the conclusion here is basically what I talked about at the beginning. You can read it on your own time. I want to finish just so that we can take a break and replenish the oxygen level in this room so you don't all fall asleep. And that's it. Okay, so let's take a break. Come back in 15 minutes and we will get much more complex. All right? Please get up and go out and let's re-air.